Hello everyone and welcome to the Student Robotics 2022 virtual Kickstart event. We're here, we're ready to start off this competition year, and it's going to be a doozy one. As the slides say, this is a virtual Kickstart, but the competition is by no means virtual. We are intending to run a physical competition this year, go back to how we've done things before after 18 months of weird, funky virtual hiatus. We're going back to what we do, and we're going back and doing, and we're hoping we're going to end up with a very, very strong competition. So, as I say, we are currently at the Kickstart event for this year, and so over the next sort of hour or so, I'm going to run through a couple of things with you. So step one is go through what actually is Student Robotics. Step two, we're going to go through what the schedule for this year is going to look like. I'm going to go through some tips about how to design your robot. Go through some tips on how to build your robot, how to develop your robot. We're going to go through some health and safety things. I'm going to go through the game. We're going to tell you exactly what you are here to do for this competition year. And then we're going to go through our micro games, which are a gamified way of getting you sort of familiar with the kit, with programming it, and just generally sort of start off this competition year a great way. So this is virtual, and so I can't hear you if you're shouting and saying things at your screens. If you have any questions, please sort of point them in the direction of our chat. We'll make sure that they will get ferried over to me as soon as we have things for you. So, what is Student Robotics? Student Robotics, we are a UK-based charity, and our mission is to bring the excitement of engineering and the challenge of coding to young people through robotics. The way we do this is by running an autonomous robotics competition every year for students aged 16 to 19. It's an annual competition, and said competition is run entirely by volunteers. Student Robotics is all volunteers. We give our free time to make this event possible and to make it what it is. And what you're coming here today, this is your start. We've been working away behind the scenes for weeks and even months, or in some cases years even, preparing and getting everything ready so that right here, day one, everything begins. There are a lot of us, and we are here to help you. You are the teams. The competition wouldn't really be much without teams. This year there are 31 of you, 31 different teams from, well, all over the country, in fact. Most focusing around sort of London and the south, but also stretching up as far as North Wales, Coventry, and even we have the ladies' college from Guernsey as well. So, the competition year starts today. This is day one. You now have roughly 5-ish months to design your robot, prototype your robot, build your robot, do all of the electronics, and oh, please do them better than this. I can say that because I did those ones. You'll also need to write a lot of code, and of course, above all else, you'll need to work as a team. Work as a team. You will also need to test it a bajillion times, a literal bajillion times. Testing is very, very important, and I'll get on to more about that later on in this presentation. After that, you will need to get your robot inspected, probably by someone slightly more competent than my cat, but whatever works, we'll see. You'll also then need to compete, hopefully with something slightly more advanced and sophisticated than a Henry Hoover. Please. Additionally, you'll need to compete some more, and even more. And throughout the entire competition, your robots will meet a lot of other robots, and you'll meet the other robots. You'll also meet a lot of other people, from sort of far and wide, all over, from various different walks and backgrounds of life. You'll need to score some points, and the reason you want to score the points is so you win some prizes. There are lots of prizes in this competition, and we'll go through exactly how you can win those prizes later on today. And of course, above all else, we're here to have fun. We hope this competition event will be fun for everyone involved, and that's sort of why we're here. Or, well, prizes also help. So, what does the schedule for this year look like? So today we are at Kickstart. It's the 13th of November as I say this. Christmas is soon-ish, but not so soon that we need to talk about it. After that, we're planning on having a bunch of tech days. These are chances for you to work on the kit with a lot of intense oversight and input from us, so we can help you and mentor you with exactly how you want to do things. We don't have confirmed dates on these, and we're not sure whether they're going to be physical, virtual, or things like that, but I'll go through some more details like that as time goes on and later on today. And then around April, we will have the Easter holidays, and then after that, the competition sometime around April. So, what exactly does a robot look like? Well, robots come in all different shapes and sizes. We've got some that look like and apparently are made out of cardboard boxes. Some that are very versatile looking, made out of, in this case, laser cut plywood, which is pretty cool. We also have some very weird ones that in this case look like spiders. Doesn't really matter. Or even weirder still, we have the car wash. Interesting idea. It all depends on exactly what your tactics are. But given robots come in sort of all different shapes and sizes, how should you go about designing them? Well, first and foremost, read the rules. That's why we write them in that. That'll tell you how the game works, what things you need to conform to, and everything else. Very, very useful. Make sure you read them. On top of that, you'll need to think of, okay, well, how is my robot going to move? Is it going to use wheels? Is it going to use tracks? Is it going to use legs? Doesn't really matter. You just need to make sure you think about it. On top of that, you have exposed mechanisms. Exposed mechanisms are bad. You'll get various things caught in them. Fingers, wires, other robots, other parts of your robot. Anything. Make sure that they're not too exposed and that things are protected. On top of that, you've got the possibility of driving servos. Servos are really useful for precise movement, but they're not so good for sort of driving around. So you may want to sort of think, okay, well, use servos where you need servos and don't use servos where you don't need servos, basically. On top of that, you have couplings. You can't sort of hold two pieces of wood next to each other and assume, yeah, they'll hold, they'll stay together, they'll be fine. They won't. They just won't. They won't at all. So you'll need to make sure that you're sort of aware of how you want various bits of your robot to stick together. You'll also need to work out what size you want your robots to be. This year there's a size constraint on our robots. They can fit into the arena in a reasonable way. So you'll need to make sure that you don't extend that sizing. 50 centimeters cubed is the upper extent to that. Please don't just build a 50 centimeter cube box. That'll look particularly weird. And as we've shown earlier, there are lots of different ways you can do things. On top of that, you'll need to work out how you're going to build your robot. You can't build things with tools you don't have access to, so you'll need to make sure that you incorporate that into your designs and build something which is physically realizable, as people like to say. You'll then also need to make sure, you'll need to work out how exactly you want your robot to be able to sense its environment, because as we say, these robots are fully autonomous. There is no remote control at all, so the robot needs to understand its environment to work around it properly. So there are lots of different kinds of sensors. These are just a couple that we see used quite a lot, so I'm going to go through some of these. So you could use things like computer vision, which I'll talk about in a while, but we'll be providing you some computer vision bits. You could use bump sensors to find out when you're driving into something, light gates to check when something passes a beam. You could use potentiometers, accelerometers, gyroscopes to work out sort of how your robot is moving, and wheel encoders to find out for sure exactly how many rotations a wheel has done, so you can get accurate distance and movements measurements. So along with the sensors, you're going to have some form of electronics, and you're going to need to work out, okay, well, where's that going to go? How long do the wires need to be? Are they actually going to reach? You'll need to make sure that the start-stop button is easily accessible. So you can go in and easily start the robot, but also so that in the competition, we can quite easily get into it and hit the power button and stop it. You'll also need some USB ports to be accessible, not sticks. You'll need two to be accessible. One that will contain your code, and one that will contain an additional USB drive that we will provide at the competition. And right at the end as well, you'll need to make sure that the battery that the robot runs on is properly protected. So, what exactly does a competition look like? So this video is taken from the 2019 final. So as we can see here, this is a 4-robot game where all 4 robots start in the corners, and the aim of this game was to grab the tokens, the cobble boxes, and deposit them into the squares across the ground. The idea being that based on territory control, the more squares you own, the better. And as we can see, various different shapes of robot, various different strategies, and what we're about to see is a very interesting one from TLC, where they fire the token into the middle. The reason for that was that the further into the center it is, the more points it's worth, and so by doing that, they were very reliably and very accurately able to get the token in there. As well, robots decide to try and flip on their back, and we can see sort of littered around quite a lot of the objects in this arena. There are these sort of, they're not QR codes, but I'm going to call them QR codes because it's easier. These sort of 2D barcodes, as they're called, which are used by our vision system so that the robots can work out, okay, what am I looking at? How far away is it? What orientation is it? And things like that. And you'll see more of those as goes on once I explain sort of how they work. That's not skipped. Why is that not skipped? No. Okay, technical difficulties. Hold on a second. Ah, tabs. Okay. Ah. There we go. So, recommended steps. What do we think you should do? Well, step 1 is make sure that you test your base as soon as possible. You want to get something moving, and you want to get it moving soon. Additionally, there's a couple of things we need to think about. Mechanics. How exactly is it going to move? How's it going to sense? And what strategy is it going to take? On top of that, you're going to want to make sure you can iterate on your design quickly. You're going to want to make sure you can do small improvements and make sure that you keep it working. If you make a huge change and it completely breaks, then that's going to stop your momentum, and you're not going to be able to do things quite as easily and quite as quickly. So on top of that, you're going to, as I've said several times, and I will continue saying throughout this entire presentation, testing. Lots and lots of testing. So, the kit. As many of you will have kits from previous competitions, and the rest of you who don't will have been sent, your kits are on their way if you've signed a disclaimer form, and everyone else, if you've not signed a disclaimer form, sign the disclaimer form, email it in, and then we can get your kit sent out to you. So, the different components of the kit, because there are several, we have, number 1, we have the brain board. The intention for this board is it controls, well, it's the brains of the operation, really. It controls sort of, this is where your code runs, this is what controls all of the other boards, and that's your robot's brain. On top of that, we have, why did I change scene? There we go. So we have the motor board. It's a very aptly named board. Each motor board can control 2 motors. You have 2 motor boards. 2 times 2 is 4. So you have the ability to control 4 motors. We don't provide the motors, so you'll need to source those. There's some instructions on the docs as to exactly what kind of motors these controllers can drive. On top of that, we have another aptly named board, the servo board. The servo board controls up to 12 servos. And these servos can be used for things like finer movement, like we saw with the spider earlier. Servos can draw quite a lot of current under load, so be careful not to strain or burn them out. And again, we don't include servos with the kit. So, another important board is the power board. The power board is what handles power distribution to the various other components in your kit. It's got high current 12-volt outputs, low current 12-volt outputs, and a couple of 5-volt outputs. It's also where you will find the start button and power button for your kit. It's also got a very small piezo buzzer in case you want to try and play music, because why not? This is the board which connects directly into the battery and is what powers all of the other boards. It's also the only board that should connect to the battery. On top of this, we have a Arduino, which is a board which uses, which you can use for general purpose I/O. So think of this very similar to if you've used a Raspberry Pi. They've got GPIO headers. This is very similar to that, but just on a board. Very similar to a Raspberry Pi, but it also supports analog, digital, and PWM. There are many different use cases for this. Bump sensors, pressure sensors, light gates, ultrasound, all of these things. And with all of these, the sensors aren't included, but there's some documentation on exactly how to get some of these things set up. If you need to do things like adding custom firmware onto the Arduino for adding support for things like ultrasound and PWM, then that's also completely possible and is fully documented in the rules. Now, the battery. Batteries should be respected. You should follow. We have a lot of battery charging documentation on the documentation. You should follow them to the letter every single time. It will make sure that that will make sure then that your battery remains sort of fully operational, fully forming, and remains safe. And you should only ever connect them to the power board when you're actually running your robot, and the supplied battery charger. You should never plug into anything else. And as I said earlier, you'll want to make sure that you protect your battery from mechanical damage, which basically means don't stab it. Don't stab the battery. And definitely don't try and like over discharge it. The kit will warn you if the battery is too low. On top of that, if you're ever unsure of exactly something about the batteries, just come and talk to us, and we can definitely help out with that. If you're concerned about the battery, definitely talk to us as soon as possible. So, as we saw in the previous 2019 competition, littered around the arena were these 2D fiducial marker barcodes. These, for this year's competition, they're only going to be on the arena walls for reasons I will get onto later. With these, you can detect various different things about these markers and exactly where they are. You can find out what type they are, whether they're on the arena or what they're on. The ID, because each one is numerically unique. You'll be able to find out how far away it is from the webcam. You'll be able to find out its position relative to the webcam, and you'll be able to find out exactly which orientation it is. There's very, very many different orientation methods you can use for this, and hopefully sort of with some very, very complicated maths, which I can't even begin to try and understand, you'll be able to take some of this and use it to do full geolocalization inside the arena to work out exactly where you are, which is very useful for doing very precise movement. Now, your code. As an engineer, this is the bit I care about the most. This is how you will be controlling your robot. So with this, your code will be Python. Python is a great language, says the full-time Python developer, but that's besides the point. We're going to give you a module to actually deal with interfacing with your robot, so you don't need to deal with, okay, well, how do I talk to a Arduino? How does that work? How does the motor board communicate? We've dealt with all of that for you, and there is nice documentation on how to use our API. Additionally, you'll be doing all of this development locally, which means that backups are up to you. You will need to make sure that you back up your code. You'll put it on a USB drive and put it in the robot, but you'll need to make sure that it's that you don't lose it. Additionally, there is almost certainly more than one of you in the team, which means you'll need to work properly as a distributed team, particularly if you're not able to work in the same room. This can be a challenge. It is a difficult thing to do. If you want some sort of tips and tricks on how to work properly as a distributed team, come and talk to us and we can help you with that. And of course, as I say, once you've written your code, you'll zip it up, put it in a zip file, put it on a USB drive, plug it into the robot, and the robot will work. Now, as I have mentioned throughout all of this, there is far, far too much information to try and sort of emit in a live stream. So all of this and more is written down in our documentation. Definitely go and give that a read. There is a lot of useful content in there that should hopefully explain almost everything. How things work, how to get started with things, what different Python APIs there are, and the various things like that. So definitely recommend giving that one a read. And you can find our documentation at studentrobotics.org/docs. And the link is on our website, which is studentrobotics.org. Now, as we've seen sort of slowly throughout this morning, once the links went out, we've seen a couple of teams starting to join our Discord forum. This is the best way to communicate both with us, with your team members, and also with every other team. You'll have your own private space to talk with as your team, but there are also plenty of other channels for you to talk with other teams, get support and info from us, and just sort of have a chat and socialize. It's the best place to get support and share tricks and just generally brag about how good your team is. If you've not signed up yet, very strongly recommend it. This morning, team supervisors, I sent out Discord links and login details to you. Competitors, if you've not got access to Discord yet, go and talk to your team supervisor. Team supervisors, if you've not had the link yet, come and talk to me. So, health and safety. It's the boring bit, but it is very, very important. So, health and safety. As I said, there will be a health and safety inspection, and it will probably not be done by my cat. It's very important that robots are safe. We need to know how easy is it to turn off. Can we, if it's running around with a battery hanging out the back, can we get to it and turn it off as quick as possible? I say this as an example because that happened. Try not to let that happen. Particularly if we pick it up, will it hurt us? I generally don't like being hurt by robots, so please try not to. Additionally, is the wiring messy or loose? If the robot drives into something slightly too hard, is a wire going to disconnect and the whole robot stop working? Going to want to make sure to do that. And equally, are those wires going to short on other things and cause potentially even more safety issues? You'll want to make sure to color code your wiring. Black wires should be ground, and then black. Nothing else should be black, apart from like USB cables. As well as the kit loose. Is it properly secured on? If you drive too hard, if a wire comes loose, could an entire board come loose and fly off and damage either other things inside your robot? It could damage the board, it could damage the arena, other robots, and various things like that. Is the battery protected? As I say, you don't want to stab the battery. You don't want to accidentally stab the battery either. And of course, as I say, is the power button accessible? That's very, very important. So, general tips. If you're working through this competition and you need some help, what do you need to do? Well, step one is chat to some volunteers. We are mostly ex-competitors, and we pledge to sort of watch Discord like a hawk. We know what we're doing. We've been doing this, some of us, for quite a while, and that's as much as I will say on that, in fact. Tech days. Tech days are a sort of day-long hacking session. Generally, there'll be staff full of volunteers, and we'll generally be able to sort of give advice on things you may not even know to ask for, let alone about things you know. We can help sort of, with various sort of mentoring and bits of tips like that, and also just sort of very intensely help as much as we can. Additionally, we have Discord. As I say, it's a very great instant communication platform that will get you talking not only to us volunteers who know what we're doing, but also potentially other competitors may also have already solved the problem you're having. So talk to them, and hopefully they'll be able to help you. As well as that, you'll need to make sure that you share knowledge. As I said before, you are a team. Teamwork is very important. They say it makes the dream work. But you'll need to make sure that sort of everyone knows how bits of code and bits of the engineering works, and make sure that everyone has an idea of, okay, well, what's the status of this thing? Is it ready? Are we able to connect this bit of code to this bit of code and have it work and test it? And various things like that. You don't want, for example, one person to be unavailable for various reasons and suddenly the entire project grinds to a halt for a couple of days while they're unavailable. Definitely don't want that. You want to keep some good momentum. Of course, keeping it simple. As we've seen sort of throughout this and through some of the videos, some robots look very interesting and very complicated, but that actually isn't always the best. We see time and time again, the simplest and most elegant solutions tend to do the best. Complicated robots look really cool, but just being complicated for the sake of it won't win you any prizes. Sometimes simple is better. And of course, prototype early and prototype often, which is a very different way of saying test. Try testing your robot in various different ways. Get a prototype, get a chassis sort of working as quick as possible, get something moving. And after that, you can then start on building and sort of assembling the rest of your robot, but it also means that some of the programming and strategy can begin, and that's very important. So, I've talked about everything that we talked about, various different, all the different components of the kit, some tips on how to build your robot, some strategies like that, but now is the time we talk about, okay, well, we know all of that, what are we here to do? So this is the moment I hope you've all been waiting for. This is the game for Student Robotics 2021. It's called This Way Up. And that's what it's called. This is the arena that This Way Up is played in. It is a 4-robot game. Each robot starts in each corner of the arena. Each match is 150 seconds long. And as we can see in the middle, there is a small grey square, which is a raised platform. It can't be moved. It's raised a chunk off the ground as defined in the rules. And as we can see, dotted around the arena are these small little circles. These are tin cans. There are 28 of them spread around the entire arena. As we can see in this diagram, some of them are red on the arena floor, and there are green ones on the raised platform. These green ones start the right way up, and the red ones start upside down. They all start in exactly these locations, as you can see on the diagram. In the rules, there is an annotated version of this which says all the distances from various things, so you can work out, right, where's this can going to be? They all start in known locations, and the aim of the game is to collect as many of these cans as possible and get them into your scoring zone, which as each robot starts in the corner, as you can see here, this is the bottom left corner. The starting zone is the yellow square, and the dotted line is the edge of your scoring zone. So the idea is to take the cans, get them inside the scoring zone. Now, as I mentioned, some cans are the right way up, some cans are upside down. If a can is in your scoring zone and upside down, it is worth 1 point. If a can is in your scoring zone, but the right way up, it's worth 3 points. If a can is on its rolling edge, i.e. like the edge where it can roll, it's worth 0 points. So you're going to want to make sure that you don't accidentally knock over all of your cans. There will be a small strip along the rolling edge on the bottom edge, so you can tell exactly which side is the correct way and which side isn't. And equally, you can obviously these ones, the red ones that start on the arena floor, will always be upside down, and the ones which are on the raised platform are always going to be the right way up. But there's nothing that says that, oh, okay, well, maybe another robot comes into your scoring zone and turns all your cans upside down or onto their side. You'll never know, or if while driving to another can you knock one over and move it. Who knows? So you'll need to make sure that you can detect that properly. So, as I said, right in the middle of the arena is this grey square raised platform. This doesn't move. You won't be able to move it. And so you'll need to work out, okay, well, how am I going to get the cans on the raised area off and into your scoring zone? There will also be, you can't see it in this diagram, but around the edge of the arena will be 28 of the vision fiducial markers, and so you can use those to actually get an idea of where you are in the arena, and from that you can work out, okay, well, if I'm here, there's a can there, how do I drive to it? Now, I've just said a lot of things about the rules. It's not even 10% of everything which is documented in the rules. All the various, okay, well, how does this work? How does that work? What happens if this happens? Make sure you read the rules. There's a reason that we wrote them. They are very, very helpful. It's important that you understand them. As I say, in there are the exact measurements for sort of everything I just talked about. Where the cans are, where the robot is, how big things are, how tall the raised area is, where the markers are, what the diameter of a can is. Is the can conductive and ferromagnetic? Yes. How much do the cans weigh? That's in there too, because they're not empty cans. Additionally, you can also always come and ask us questions in Discord. There is a channel called #rules, and the idea of it is you can ask us questions about the rules, funnily enough. And of course, if you have any questions while I've been talking about this, again, make sure post them in the chat, and immediately once I finish talking, I'll be able to go through them, run through them, and tell you exactly all of the answers. Now, some people would like to say it's the taking part in a competition that counts. I think that's what losers say. Prizes are everything. There are exact definitions of all of the prizes in the rulebook, but let's run through them all quickly so everyone's got an idea. So, of course, there's the obvious one. There's first place, there's second place, and there's third place. This is based on the knockouts at the end of the competition. The person who finishes first is awarded first, second, and then third, etc. Additionally, there is first movement awards. So there are 31 teams competing this year. There are a lot less than that, somewhere around 10, that have never competed in student robotics before. This prize is specifically for you. The idea is that you want to get something moving as quickly as possible. You need to build a robot, make it drive forwards, turn around 180 degrees, and drive back to where it started. Take a video of it, post it on Discord, and you'll win a prize. This is only applicable to teams who have not competed before. You can, by all means, get something moving as quick as possible, teams who have competed before, but you won't win the prize. Additionally, we have the Rookie Award. Rookies are those teams who haven't competed in student robotics before. This award is specifically for those who have placed highest in our league at the end of the league period of our competition. We run some league matches, and we use the output of those league matches to seed a knockout. The rookie team that's placed highest in the league win this award. Now, additionally, we have the robot and team image. Some teams like to turn up in the competition in fancy dress, maybe matching with their robot or the game, or both. And we really want to reward that kind of dedication and ingenuity. So this award is for the team who we believe has the best image. The one who sort of has put the most into the idea, put the greatest effort, and sort of come out with the best looking result. Additionally, we have the Online Presence Award. Now, Student Robotics exists on various different social media platforms, all sort of around the internet. We're an internet-driven charity, and we encourage our teams while they're competing to also do the same. So make sure you are active on the internet. If you're on social media, if you run a blog for your robot, if you are particularly active in Discord, all of these things count towards your team winning the online presence. If you're doing things on social media, be sure to use hashtag SR2022, and we'll make sure to keep track of it, keep an eye on it, and we'll almost certainly be retweeting and sharing a lot of it, as well as things making their way into the Teams on the Internet channel in our Slack. As well as that, we have the Committee Award. Now, this one is easiest to find exactly as it says on the screen, for ingenuity and elegance in robot design. This is the award for the best engineered robot, the best idea, the most elegant execution, the most elegant idea. These kind of things are things that as engineers we want to reward. And so we do in the Committee Award. Now that you know everything you need to do, it's time to learn exactly how to do it. And the way you're going to do this is through the micro games. It's a way of getting you familiar with your kit through a set of challenges. The micro games are in two parts. There's a kit part for those of you who have a kit. For those of you who don't have a kit yet and aren't waiting for a kit, use this period of time to take the disclaimer form, sign it, and email it into me. On top of that, for those of you who don't have a kit and everyone else, there is a simulator part to get you familiar with the API. It's a 3D virtual simulator. It's really cool. But this will help you get started with, okay, how do I program the robot? What does the API look like? And things like that. And if you don't have your kit yet, you can start with the simulator one, get familiar with how it works, and then do the kit ones once it's arrived. It's very important that you do the kit ones. As part of the kit ones, there is a step for updating the OS on your robot. This is very, very important. To those of you who already have a kit, you'll have used a previous version of our API with previous things. We have completely rewritten it from scratch for this year, and it's fantastic. So you'll need to make sure you update the kit as very, very first thing you do as soon as you get your kit. Additionally, all of the information you should need to complete the microgames is in the docs, as well as the microgames themselves. If you go to the docs, look in the sidebar on the left-hand side, under tutorials, there is a link called microgames. Jump in there, you'll get to a Google document, and have fun. Team supervisors, you should have the answers, or once you're in Discord, you'll have the answers. As well as we have the answers as well, so we can sort of help and guide you towards and support you on things. But the idea is this is a nice learning experience for, okay, how do I get started on things? What things should I start on? And the micro games are a nice, well-rounded way of trying out every little bit of the API and seeing how it works. So that's the end of the Kickstart presentation. Hopefully that's given you a chance to have an idea of, okay, well, you should now know, what do I need to do? How long have I got to do it? How am I going to do it? Why am I doing it? And various other bits of information. And so now what I want to do is sort of invite a chance for you to ask questions in our YouTube chat. Ask them there, I'll read them, see what they got. This is going to be the quickest way to get answers to any of the questions that you might have, so definitely recommend sort of asking some questions now. Let's jump over to here and let's have a look at the YouTube chat. Interesting. There are no questions. I'm going to say that's probably a good thing. Very rare that this happens, that I'm able to quite so eloquently explain everything in the rulebook so well that no one has any questions. That's not happened in student robotics history, and we've been doing this for 12 years. This is good. You can leave it a bit more and wait for some questions to come in. If you're hearing this, think you may have a little bit of a question, post it in there anyway, and our flurry of volunteers will hopefully be able to answer it. Come on, questions. So, yeah, as we saw, the game for this, I think, is probably going to be where most of the questions come in. Does the size restriction only apply at the beginning of a match? This is a very interesting one. It's from a volunteer, so it's somewhat cheating, but I'm going to answer it anyway. The size restriction mostly applies at the start of a match. Your robot has to be inside 50 by 50 by 50 right as soon as you hit the start button. After that, it can extend up to 1 meter along the edge of the arena floor. It can extend as tall as it wants upwards, if that's useful, but 1 meter across the arena floor. If at the start of a match you do not meet that 50 by 50 by 50, your robot will meet our very good friend, the Cube of Judgment, which is a 50 by 50 by 50 cube to make sure it fits, and the wonderful Saw of Shame. Yes, if your robot does not fit in that size, you will need to lop limbs off of it until it fits. So make sure you do all of the testing as soon as possible. We also have a question about, are the cans going to be empty? No, they will not. The cans will not be empty. They will be full of things. What those things are undefined because the cans should stay sealed. Please do not pierce them. But the weights of the cans, which is going to be the most important thing, are documented in the rulebook, which is on our website. A fellow volunteer has said, can, or can't a can? A can, can't, can. Sorry, Alistair. I mentioned upgrading. So our school has been playing. Our school has been playing for a few years, but new people. So do we count as a new team? I think that one makes sense. So yes, the idea is that a school is rookie or not. If, for example, you've had a couple of years where, if you've not been running sessions for a while, then you'll probably count as a rookie. We've already, in our list, we've worked out, okay, do we consider this team a rookie or not? You'll probably know if you're a rookie, or know if you aren't. So hopefully, that should answer things. If you're unsure whether you would be considered a rookie, come and ask us in Discord, and hopefully we can answer those. Cans are not going to be empty. Do we count as a rookie? No. You mentioned upgrading the kits. Does that include the ones that are currently being sent to us? Yes. 100% of kits require updating. Whether you've had them in your school for 1 year, 2 years, whether they're currently on their way to you, or whether you've not signed your disclaimer form yet and we haven't dispatched them yet. All kits must be updated. If you forget and in 3 months' time have written a bunch of code and then decide to do the update, a large chunk of that code may need to be thrown away. The API is different. It's an entirely different version of Python. You have to do the update as soon as possible. There's download links and instructions on exactly how to do that on our docs. And of course, jump into Discord if you have any issues, and we will definitely be able to help you out. Can you tell us what the cans will be, where you will source them so that we can get the exact ones? I suspect so, yes. Once we've sourced the cans and work out we can reliably get 28 plus spares, and not look like a very weird person walking around Tesco's with 30 cans plus spares. Yes, I see no reason why we couldn't document exactly which ones we are. We've put the weight and size in there, but hopefully, yeah, we can probably document things like that. Are we allowed to pierce them, though? No. No, you're not. You cannot. Student robotics is a non-contact sport, and one of the items in the regulations in the rules is you may not cause damage intentionally to the arena or any other robots or other props in the arena. The cans count as arena props, which means by definition, if you intentionally harm a can, you will be disqualified. If you do this too often and intentionally, then we may fully disqualify you from the competition. So no, you may not pierce a can. They are magnetic though, so if you want to use magnets, that's a very good way of lifting them up. When will we have access to the new rulebook? That's a good question. It may already be up. If it isn't up, it should be up within the next sort of 15-20 minutes. Hopefully, by the time if you're coming back to this presentation later and you're wondering where's the rulebook, it's on the website. studentrobotics.org/rules should get you to the right place. Are the cans the same size as a standard can of baked beans? Yes, no, it's complicated. There is no standard can. We found this out the hard way. It doesn't really exist. It's not... Yeah, it's difficult. Hopefully, once we've got the cans, we can tell you exactly which cans we have. That will help. But from that, I think... yeah, they're not really... They are standard. You can buy them off the shelf, but definitely make sure sort of wander around the tin food aisles at your local supermarket with a tape measure and make sure that you are buying the right ones. Size and weight are both documented in the rules, so make sure you give them a look. Can we stack cans on top of each other? Yes. If a can is stacked on top of another can and the can it's on is in, then the can on top is in as well. The rulebook does mention that cans can be on top of cans and how the contact rule is meant to work with a can being counted as in the scoring zone or not in the scoring zone. But yes, cans, you can, if you wanted to, say, put two cans on top of each other because it'll help with moving around the arena. Yeah, by all means, definitely possible. They are the types of cans that should, if you've ever used a food can, that feels like a very strange statement to say, but generally the cans will lock into each other. The orientations to make that happen will be correct, and we will probably be buying the cans that do lock into each other in that way. So you can sort of do things like that. Are the cans going to be covered in something? Yes and no, because I really like giving complicated answers. Most of the can will be bare. It will just be the magnetic surface that will allow you to magnetize to it, detect that it's a can, not a wall, and things like that. However, at the bottom of the can will be a small non-conductive strip, and you'll then be able to use that to tell, okay, is this edge going to be... Is the can the right way up? Is it the wrong way up? Is it on its side? Is something else weird happening? But yes, most of the can, as I'm assuming this is why you're asking the question, most of the can will be not covered, and so will be metallic and magnetic, ferromagnetic. Does can orientation matter when in the scoring zone? Yes, very, very, very much so. A can... I don't really have a... Okay, apparently I do have a can. Okay, here's some fly spray. So... Here is fly spray. It's reasonably obvious to tell what orientation it is. If your can is in the arena like this, it's worth 3 points. If your can is in the arena like this, it's worth 1 point. Can is in the arena like this, it's worth no points. Sorry, not in the arena, in the scoring zone. 3 points, 1 point, no points. I hope that's clear. That is in the rulebook as well, if that helps. Are cans QR coded or just coloured? They are neither. The colours are purely to represent them in the rulebook. The cans will look to humans like cans. The only reason they're coloured is so that in the rulebook diagram you can tell which ones are the right way up and which ones are not the right way up. The cans will have no vision markers on them, so you can't use that to detect them. As I said, they will not be covered in anything. They will just be bare tin cans. They should also be unprinted tin cans as well, so they should just be bare metal. So yes, not coloured, not QR coded, fiducial marker coded, just tin can. Yes. Hopefully this is exactly why we do these kind of QA sessions, so we can get sort of a lot of these things cleared up, so you can really, as soon as this finishes, hit the ground running, and hit the ground running fast to make sure that, right, we know all the information, let's design our robot, let's sort of think about strategy. In previous years when I've done Kickstart events, way back when, we spent a large amount of the bus ride back from Kickstart to school just brainstorming hundreds of different, sometimes completely ludicrous ideas as to how things are going to work. And I'm hoping that whilst I'm talking and waffling to myself, you are going through the exact same kind of thoughts as to, right, how is this going to work? What's that going to look like? So I can see a question. Green is the right way up, red is upside down. Yes. As we can see in the diagram here, let's jump to this slide so it's slightly easier. The cans which are in red are upside down. These ones are on the arena floor. All of the ones on the arena floor are in red. All of those cans will start upside down. Additionally, there are green ones. All of the green ones will start the right way up. All of the green ones are on the raised platform. Only green ones are on the raised platform. Only cans which are... Only cans... All of the cans that are on the raised platform are the right way up. All of the cans which are on the arena floor are upside down. I think that made sense. Yes, if you look in the rulebook, underneath there is a small key which isn't in... It's not in this diagram, it's cut off along the bottom a bit, but under there it says red can, right, wrong way up, green can, right way up, grey square, raised platform. I think those are all the permutations of language I can think of. Yes, green can, right way up, red can, needs rotating, then it will be the right way up. Green is just for the rulebook. Red is just for the rulebook. You can also rotate the cans, it's just how they start. So the red cans, the strip will be on the top, the green ones, the strip would be on the bottom. Are the surfaces of the can reflective? That's an interesting one. Will a laser type of sensor see them, or will the return beam be reflected away from the robot? I don't know. Theoretically, it is, imagine, I don't know, I've never shone a laser pointer at a baked bean can without a label on. It's whatever that does. Given it's a rounded surface, getting a perfectly returned beam may be difficult. But in theory, given they are metallic, it should reflect somewhat, as you should be able to see things. Hopefully that counts me. So I've never thought of using lasers to work that out. That's quite a cool idea. But yeah, hopefully that answers things. Oh, and yes. So it was alerted to me that so we've changed the diagram in the rulebook because red and green color blindness exists. So we've updated that, so hopefully it's a bit easier to distinguish. If you are unable to tell the difference between red and green, hopefully that makes things a bit easier. But it's also written in the wording of the rules that cans on the raised area are the right way up, cans on the arena floor are the wrong way up. Yes, so we've improved our accessibility on that, and hopefully that helps. Let's see, another one. If the cans are just bare metal cans, how will we know that they are the right way up? They're almost bare metal. There is a small strip around the bottom. I never got a chance to make a diagram, but yeah, so I'm going to use my... let's try and not hit the mic. I'm going to use my can substitute again. So it's obviously not this dimension of can. It's a food can sized. But there will be along the bottom a small strip that is non-conductive, which you can point something at and work out, okay, is it conductive or not? And from that work out, is it the right way up? or is it the wrong way? Actually, this can works well because in theory that bit's conductive and the plastic lid is not. So yeah, that's how you'll be able to tell whether it's the right way up or the wrong way up. And so obviously we don't flip where the band is. The band will always be on the bottom, whether the can started on the raised platform or not. The cans are identical no matter where they start. The point is that they start either the wrong way up or the right way up. Hopefully that made some level of sense. What's the arena floor made up of? It is in the rulebook. It is short pile carpet. Yes, it's short pile carpet. If you've done a competition before, you'll know what that means. If you've not, it's short carpet. Carpet tiles are very similar to that style thing. If you've got carpeted rooms at school or in your house, if you've got relatively thin carpet rather than big ass carpet, it's that kind of carpet. It's that kind of carpet. We may be able to get some samples before we actually build the arena, but yes, it will be carpet. It won't be sort of laminate floor or like rubberized. It will be short pile carpet. Yes, short pile carpet. I'm going to say that another time. Short pile carpet. That. So this may be the end of questions. Last competition had a very different carpet to previous years. Technically true, last competition was virtual and we didn't virtualize the carpet. 2019, if you attended that competition, as far as I remember, we are using the exact same carpet for this coming year. Hopefully we might be able to get some like photos of what short pile carpet is, what it looks like, and potentially be able to get some if we do some in-person tech days. Then maybe we'll cut a strip off and bring it up. Oh no, the last one is Southampton. Yeah, it's that carpet that we're using, the one that we used last time in Southampton. Will the can filling be solidly fixed inside, i.e. not a liquid sloshing around inside, or a loose powder that can flow? That is a very good question. Basically, if we overturn it, will the center of mass change? Yes, I think it will. It will probably be sort of food cans, which won't be, it won't be like a solid jelly thing inside. It will probably be something in a somewhat liquidy state, so its center of mass may change when you rotate it. Once we've worked out what cans we're going to use, we will definitely be updating the rules to reflect that, but I suspect that it will not be solid can of mass. It will have a thing inside it that can slosh. I mean, baked beans don't really slosh in that sense, but I suspect that's the kind of slosh. It's not going to be like water where it will properly change very quickly and only be sort of like partly filled up. Are cans on the raised platform on the edge, or will the robot have to get onto the platform? No. So you can kind of see it here, but not quite. The green cans, actually, I have a laser pointer. There we go. So the edge of the can lines up with the edge of the raised platform here. Sort of, exactly. They will be flush against the edge. Yes. In theory, there is nothing in the rules that stop you climbing onto the arena, onto the raised platform. For example, if you decide, right, I want to jump onto here, grab all of these from on top, and then climb off. Perfectly valid strategy, very impressive feat to do. So yeah, the raised platform won't move either if you do that. But yeah, those cans will be very much flush to the edge. The measurements sort of from the corners here as to how far along the edges they are. Oh. I've just been informed that I've been pointing with a laser and you've been staring at my face. I'm so sorry. Here we go. So back on here, we have... so here we go. The green can is right flush up against the raised platform. So you can drive up, jump onto here, grab all of these green cans, and then climb off. And that's giving you what? 2, 4, 6, 8 cans all the right way up that you can just drive off, depositing your scoring zone, and that's what, like 24 points, which is huge. When and where will competition be? Yeah. Oh, I can see someone is trying to type and tell me something. See what they're saying. This is why I said get your questions in early, get them in quick, and then we can answer them. So here we go. Yes. When and where will the competition be? That is undefined. As I said in one of the previous slides, where is it? Scheduled for the year. There we go. So yeah, competition April time. We will try and keep it as far away from exam period as we possibly can. The competition will be sometime around April. We don't quite have the final details, but we are endeavouring. We're very close to being able to go. Let's do this. But it will be in April. We're just getting the final finishing touches on our bookings, and then we'll make sure to announce them as early as possible. We are in previous years it's been difficult, but we are trying to get them done as early as possible because we know, particularly with this year, as much notice as team supervisors can't have too much notice on when the competition is going to be. We were really close on getting the booking done, so we could do something we've never done in student robotics history and announce the competition date at Kickstart, but we didn't quite make it and we weren't quite confirmed. So we'll see. Yes, we don't know yet. Are there built-in routines in the software Are there built-in routines in the software which will return the can's orientation? No. You'll need to work out, mostly because there's nothing, the software doesn't know what a can is. On for the producer markers in the vision, you'll know what way up the arena is, but if it's ever not the right way up, you may have done something a bit wrong. Cans don't have these vision markers on them, so you won't be able to detect them with vision. If you want, there are various different ways you can use the non-conductive strip as an identifier to work out which way up or whatever it is, but you'll need to work out, okay, well, how do I, if say you wanted to use 2 wires and check if it's conductive, okay, well, how do I drive up and check that I'm contacting something, and then how do I pass a current through the wires to make sure that it's conductive or it's not conductive, or if I move it up 4 centimeters and it is conductive, is that definitely the bottom? All of that stuff you'll need to work out for yourself, but the API is for pass some current through these wires, please, and move a servo up a little bit. Those are in the API, and you will be able to do that. So can other teams come into our scoring zone and knock everything over and vice versa? Absolutely they can. Yes, anyone can. The only thing that matters is the end state of the match. That is the most important thing. What happens when the clock strikes 0 is how the match ends. If you bring some cans into your scoring zone and end up with like 50 points, and then something goes wrong and you or another robot pushes them all out right at the end, nil point. no points for you. So you got to make sure that it's right at the end that the points count. And yes, you can just drive into a scoring zone. If there's cans there, you can steal other people's cans. Particularly, there might be a strategy there if they've turned them up the right way and you haven't. There's a technique in there. You can rely on your competition rotating them and then steal them off them. Yeah, you can. Robots can drive anywhere. It is a non-contact sport, so you can't barge into other robots intentionally, and you definitely can't intentionally damage the arena. And we highly recommend you not just drive full force into something because you might risk breaking yourself. But yes, drive around, drive exactly where you want. Anywhere inside the arena is up for grabs. You can't climb out the walls. You can't drive sort of jump out here and drive around. That's not allowed. But everything else, by all means, go for it. Okay. I keep saying this several times. Ah, yes, that's the end of the questions. And then some really great questions come in. I'm not going to say that this time. Let's wait and see what other questions come in. Won't keep going too much longer. If you do have other questions that I don't quite get to in Kickstart, then you can definitely come and ask us in Discord. We should be reasonably well staffed throughout the rest of today, but also throughout the rest of this competition period. There are lots of us around, and there are lots of competitors in Discord. Ask questions whenever. Don't necessarily expect an immediate response. Some of us at least do have lives, but definitely ask questions in there. We will definitely try and respond to them as best we can. So, let's see. Any more questions? Stunned silence, I'm assuming. Aha! If the cans are in the robot and the robot is in the scoring zone, does that count? It depends. It depends what in the robot means. If you like take a can and put it on the robot and then like drive back to your scoring zone, but don't put that can on the floor, that won't count. Cans have to be in contact either with the floor or with the wall inside the scoring zone. So yes, that doesn't quite work. You'll need to make sure that you deposit your can into your scoring zone, and you can't like hoard all the cans and like fill up a sack with dollar signs written on it, or pound signs, I guess. Move into your scoring zone and know that no one can take them. You can't do that. They won't count. In theory, you could deposit them all very quickly right at the end, but I probably wouldn't depend on that working fully necessarily. It's a very risky strategy. Will we know which corner we will be in advance of each round? Yes. So as I mentioned before, you'll need to leave 2 spare USB ports on your robot, which are both easily accessible. One, which will be the USB with your robot code on, so you can easily get at it. Second is what we're calling the competition USB. So when you turn up to a match with your robot you come to staging, turn the robot on, get it ready, you'll also be given a competition USB. And what this does is it tells the robot, A, this is a competition, and B, I start in corner 0, for example. Exactly which corner is corner 0? The top left one is 0, and then 1, 2, 3. But that is also in the rulebook. So yes, you'll need to make sure that competition USB stick is spare, is free, and is easily accessible. There's no real way of getting around that. yeah, that'll be the way that you'll be told what zone you're in, and also that it's a competition, because then it means that when the clock strikes 0, the robot automatically stops. We intentionally don't do that in development because it would be really, really annoying for quite a lot of things. Yeah, hopefully that answers that one. Things are slowing down a little bit. So I think with this, what I'm going to do is say that is it. It's been just over an hour. And hopefully that's given you a bunch of information on, okay, how does this year work? What do we need to do? How are we going to do it? How does our kit work? Where can I go to find out more? The docs, test things, various things like that. If you have any other questions, please post them into Discord, and we will definitely be able to answer them, and best of our abilities. And we very much look forward to seeing you at our next Tech Day events or at the competition. Good luck.